Hello everyone, welcome back. So today we will be entering chapter 11, which is on deformation of solids. So there's two subtopics in this chapter. The first one is on stress and strain. So in this subtopic, you should be able to distinguish between stress and strain for tensile and compression force. And then you should also be able to discuss the graph of stress strain for a metal under tension. So in PSPM, we will only be focusing on C3 and C4, which is a calculation part lah, solving saja. So the part where you have to distinguish between stress and strain, it is for your UPS lah, soalan-soalan UPS. It focuses more on C1 and C2, your understanding of the chapter lah, which is meaning the theory part of the chapter. Okay, so when it is asking you to discuss the graph, you should be able to draw the graph lah. Sometimes in PSPM they ask you to draw the graph, so you should be able to draw the graph lah. Okay, alright, so stress is defined as the ratio of the perpendicular force to the cross-sectional area. So mathematically we can calculate the force to be equal to this. What do we call this? I forgot. This is I don't remember. Okay, so an object being stretched by a force as shown here will cause the extension of the rod. Okay, so if an object is being pulled or pulled this type of force, the object is undergoing ataupun it is experiencing a tensile stress lah. It is known as the tensile stress. If dia push macam ni pula, it is known as the compression. It is experiencing a compression stress lah. Okay, ataupun compression force. This is a compression force. This is a tensile force lah. Okay, so stress is a scalar quantity and it has the unit of Newton per meter square ataupun Pascal. And then strain, this is epsilon. It is defined as the ratio of extension ataupun elongation to the original length. Okay, it has no unit and it is a scalar quantity. So mathematically we can calculate the strain using this formula here lah. Okay, so this is a stress against strain graphs. So based on this graph, ductile materials would undergo plastic deformation first before breaking. Okay, so before it breaks, it is able to undergo a plastic deformation lah. And then for brittle materials pula, it will not show any plastic behavior, so it would directly break, for example glass lah. Okay, so this label here is actually for these graphs here lah. Yeah, so okay, before that let me just add a few. Actually it's the same with the one here. Never mind lah, sama aja. Okay, so let's look at this graph. Okay, so this is the explanation. So from point O until point A, the force ataupun the stress increases linearly with the strain. Okay, it will only increase linearly until point A. Okay, so the formula that we can use is the Hooke's law. Okay, it states that below the proportionality limits, the restoring force will always be directly proportional to the extension. Okay, so at this point here, it obeys the Hooke's law. Okay, and then the negative sign here indicates that the restoring force is in the opposite direction to an increasing extension. Okay, and then at point B pula, point B, tengoklah point B sini ni, it is the elastic limit of the material. Okay, so beyond this point, the material will permanently stretch. Okay, so it will never go back to its original shape ataupun length. If the force is removed, the material will have a permanent extension. Okay, so it will extend. Okay, it will have a permanent extension macam ni, OT ni yang bagian strain. Okay, and then the area between the two parallel lines, which is AO dengan CT, it is representing the work done to produce a permanent extension OT. Okay, so OB region ni pula, OB region is known as the elastic deformation punya part lah. Okay, so at this point it is known as the elastic deformation. After that point, this is known as the plastic deformation. Okay, at point C pula, the yield point mark a change in the internal structure of the material. So meaning that the layer of the atom slides across each other, causing an increase in extension lah. Okay, so that's why when an object is being pulled macam ni, at the center they akan thin out kan, they reduce. This is because the layer of atoms is sliding across each other, resulting in an extension lah. Okay, so the material will thin out lah. Okay, right, and then at point CDE ni, this region is known as plastic deformation. So when the force increases, the extension increases rapidly. And then at point D pula, the stress on the material is maximum. So at that point, it is known as the breaking force. Okay, breaking force, where the point is also called as the ultimate tensile strength. Okay, that is the maximum tensile strength it can experience. After that, the material will break ataupun it will fracture lah. Okay, alright, so this is the stress strain graphs for various materials. Yeah, you can just read this, and then this one is for the stress and strain graphs for rubber. Okay, rubber undergoes elastic deformation. It can regain its original shape and length. Okay, so it does not obey, but it does not obey Hooke's law. Okay, so the strain produced when decreasing the stress, which is from point X to point Y here, is greater than the strain produced when increasing the stress from point W to point X lah. Okay, and then the shaded area ni, it is known as the hysteresis loop. And then it represents the energy lost per unit volume, which is lost in the form of heat lah. Okay, so remember, rubber undergoes plastic deformation lah. Okay, remember the type of loop, which is hysteresis loop lah. Okay, alright, that is on subtopic 11.1.